Good morning, everyone, and welcome to today's webinar, The Power of Creo 10 Part 1 Simulation. Presenting today is Mikko HInkkanen, and I will be your host and sidekick today, and my name is Carolina Hägg.
Simulation components of the Creo Parametric, what's new on the Creo 10. So let's go on it. So there will be, let's say, multiple applications for this kind of simulation in Creo, and we try to cover them somehow, by just highlighting the key or the most biggest news that there is, not really going to all the nitty-gritty details of what's new, what other kind of small enhancements they are, but we just try to concentrate on the major enhancement and major new things that are coming up with the application. So, and for this webinar particularly, it is about simulation-driven design. So what kind of fun tools we provide for design engineers to start simulation early in the product development phase, and for structural analysis and fluid flows, and for the generative analysis, what do we have in there? So let's go on the road from here. As we have multiple products, and even our own stuff is sometimes mixing up the naming of these things, I try to concentrate, make it this kind of a crystal clear for everyone what I'm talking about here. So Creo Simulation Live is an Ansys product that is embedded in Creo Parametric, and it's using the display graphics card for computing the results fast. And it has two license options, Creo Simulation Live and Creo Simulation Live Plus, which then later enables you to compute the fluid flow in your designs. And if you look at what's new on that one, we have a contact in simulation in structural analysis. And so far, there hasn't been any contacts. Everything has been basically bonded together rigidly, which then is kind of leading to models which are overly stiff, and the displacement result starts to get at some point a bit off, let's put it like that. And nowadays, you can have a contact in there, and options are still the bonded, the free, and then you have also kind of a no separation, which is intended for small sliding and frictionless contacts. So still, this is quite okay for the computing the bolt joint kind of structures, but if you look at the plastic kind of a snap joints, then I would say that then you are stretching the limit of what it can do. Then the second thing is that when it comes to fluid flow, we also have ability to have a nice vector results, and also the results for the structural analysis has been updated. I try to make you a small demonstration on these capabilities after the slide deck has gone through, as with the live software. So that was Creo Simulation Live. Then we have something completely different. It's a Creo Ansys simulation. Again, it's an Ansys product that is embedded in Creo Parametric, but it's used a CPU for the solver. In there, you also have a two license level. You have an Ansys simulation, and recently they've been announcing that there is now a Creo Ansys Advanced simulation license version of the applications. And so, what do we do in here? So we have now, if you just click display, what we have now is a contact, which is a non-linear. And there's a few formulations for it and a few kind of fun options for your contacts. But still, the main point is that you can today make a contacts in your simulation models and make the model behave correctly, so that you will get your relative movement and you get your kind of result values for the surface pressure and also the residual forces and all that kind of stuff what you need. And you need a Creo Ansys Advanced license in order to get this functionality up and running. Second nice thing is that you can also push these models to Ansys mechanical solver if that is what you want. So in here on the background, the user is changing the result types from the displacement to surface pressure to sliding and all the kind of things that you need for analyzing your results of that mechanism. But in general, the modeling has been improved with that. Secondly, with these new contacts, you also upgraded how the contacts are detected. So either you can go with the automated contact detection, or another option is you manually create them. Either you go for one by one, so this surface can attach to that one, and this can go to that one. Or you can also use the one-to-many or many-to-many kind of relations between the surfaces. And that's quite nice, since that enables you to pick a pile of surfaces which can then slide over each other, like on that snapshot, what is going on in video. There the user is selecting multiple surfaces which can then slide over the second set of surfaces while the red piece is moving from the right to left. And then on the dialog, there's also this repeat button which enables you to go on a bit faster setup of your models. Then also with this Creo ANSYS Simulation Advanced license, there's now possibility of on top of that contacting, also possibility of using a non-linear materials. And typically these can be this plastic or rubber kind of materials which are described by neo-hook and hyperelasticity, where you have a relatively small strains, but you also have a very large deformations, like a rubber seals or rubber bolts like you have on the video on the right. Then second material model that you have is linear orthotropic elasticity, and typically use composite materials to describe. Composite materials are described using that one. So you have different stiffnesses to different directions, basically. It's like a wood. You have a grain direction and orthogonal grain direction, and those have a different properties in there. And then the third one, bilinear plasticity, simply means that, which is on this graph on the right, so that you have this standard linear Hookean law area, and after that you have a second linear area, which is tangent modulus, and you use that for describing the yielding. So post-yielding simulation is nowadays possible. Also, what's possible with this advanced license is that you can combine the physics of thermal and structural. In this Creo 10 release, now it's possible to simulate the thermal expansion use case, so that you have some temperature distribution, which then can be used for loading of the model. And it doesn't really matter which way you go. You can either compute your thermal distribution first and then go for the structural, or vice versa. And also this kind of requires the advanced license. So new functionality has been embedded to Creo 10 quite heavily when it comes to this Creo ANSYS Simulation Advanced license. Then we have something completely different. There is this product called Creo Flow Analysis. It's a symmetrics product that is embedded to Creo Parametric using a CPU as a solver. And there is 3 levels of licensing: basic, advanced, and premium. And it's been there for, let's say, past 3 releases. And on this Creo 10 release, while we compute the fluid flow or the conical heat transfer, what is improved in here is how do you visualize the results. Nowadays it's possible to use the spares or arrows or scale the size of them and relative amount of them while you're creating results. Then on the other hand, the controls for how fast they go, or how which way they go to the system to visualize the flow field, you can now manipulate it a bit more than previously. Also, post-processing has been enhanced so that the GIF files that you can create out of these are now much easier to create. And also what we're doing is that you can now store the post-processor settings with the projects, which we previously couldn't. and also the base product or the solver is now been upgraded from the Symmetrics. There is also some other things upcoming with the Creo 11, which is something like 9 months away from now. So looking good with this product that it's developing steadily and making fluid flow computation available to each engineer with quite low threshold to start working with it. Then the fourth one, the Creo Simulate. This is a PTC product and use a CPU for solver and has been there for the, let's say, from the 1980s or something. And we have two basically different licensing flavors on it. You have either Creo Simulation Extension, or then you have a Creo Advanced Simulation Extension. And you can use also something called Fatigue Advisor to beef up the capabilities if you want to compute something on the fatigue. And the development of this thing has been, let's say, quite sluggish during the last one latest release, but now something magical has happened. First of all, what's there as a basic improvement is that you now support for multi-bodies that came with the Creo 7. So now that you can use a body as a reference for multiple things like heat loads or let's say interface detection, like for contacts between the bodies, and also the materials can be different for each body. So that kind of supports very nicely the approach that if you model something on the part level using multi-bodies, you can also simulate those bodies and how they interact with each other. And somehow making it more compact, at least for the beginning of the design. So this kind of now supports that body definition to end. Let's put it like that. Second thing what's been doing in here is that now, since the Creo 10 is also giving you the composite design in on the design side of the thing, on the application, we also support that in the Creo Simulate. So previously it has been possible to simulate composite materials in Creo Simulate, an advanced version of that license. But then what you have to do is simulate that as a quilt, which you are then defining a shell model, which contains all the plies. And just applying those plies can be a bit tricky since you have to know where the one ply ends and what is the orientation of the ply and what is the thickness of the ply and so forth. But now the system can read that all that information about the internal ply structures directly from the design model, which of course makes less error prone and much faster to simulate to start using it. Second thing is that from the design environment, there's also a draping simulation in there, which means that if your fabric starts to go wrinkle, it will warn you before you realize that on the shop floor. But that is really part of the design environment instead of the simulation environment. But how does it look? Well, after you create your models in the new composite design environment, you can see maybe my mouse. So there's a new tree on the Creo Parametric that tells you what's kind of a laminate, what is the laminate structure for it. And after that, you can push it to Creo Simulate, just use the existing definition, and then just compute it. So basically, the only thing you have to define at the Creo Simulate are the forces and boundary conditions. So basically loading. And that really drives the efficiency of designing the composite laminates. Also, the nice thing in here is that you can now export the composite design to, for example, direct to Nastran or use the HDF5 export format to push the kind of a whole design to third-party applications for in-depth analysis of what is really happening in here for dedicated applications. Then we have a generative topology as one of the theme. So this is the PTC product that uses artificial intelligence and machine learning to really drill down the optimal geometry for particular load cases. So you can have a multiple different load cases and optimize the design against all of them. And you have two different basic variants of this application. You have either a generative topology optimization extension, which is using the local hardware, or are using a design extension, which is then using a cloud-based approach for it, so that you can really start crushing your numbers with that. So let's go and see what's new in there. So again, we have a new load cases available, and load cases can be something like a rotational symmetry. So rotational symmetry, this means that you have a kind of a pizza slices in there, which are all similar, and we have a, let's say, number of them to complete the whole circle. So in this case, for example, you have 5 spokes in here, and just make sure that each of them are similar to each other. And then you are using that information to develop this geometry. And of course, the benefits of that is that that will be a radially balanced. You don't have kind of inertia forces to that unsymmetric kind of geometry. And then on the other hand, you will get faster of what kind of geometry you want. So basically, if it's a rotational in the let's say the optimized rotational, and you know it beforehand, you also can now control and drive it towards that. Second new load case for generative design is that you can use remote forces, which means that there's a force which is acting a few meters away from some distance away from your piece, and but it's affecting certain surfaces. Then of course you will get that force on those surfaces, but also moments related to them. And now you can use that kind of a definition as well. And the options are that you can either model it rigid or deformable, which then gives you yet another kind of latitude of how do you want to simulate or load your kind of a geometry in order to find the optimal solution. So a new kind of capabilities of describing the loads. Second, which is exactly related to this one, is the point masses, so that instead of creating that kind of a red bulky thing, which is loading your model as an external kind of a piece, which this support structure has to hold, you can instead putting just a datum point in there, define a mass for it, and then you have to just put a centrifugal or let's say gravitational acceleration to make it act on something, because mass itself doesn't act on anything. You just have to have some acceleration to make it load for something, for the structure. And this is available for the modal and structural studies, and for the modal particularly, if you already know that some of the components are very, very stiff and don't really affect to, let's say, the stiffness of the whole structure. It's much more about how to design the supports and find out the lowest kind of natural frequencies of them. Then sometimes it's much convenient to just replace some of the devices just with the point masses, attach them to surroundings, and make the system compute in order to find out the supporting structure kind of modal frequencies. But it makes it easier and faster for you guys to make it happen. Then the last one, the last slide as well. Now it's also possible to measure between the geometry and hybrid body. So when you create some geometry with geometrical topology optimization, you are creating a so-called hybrid body, which is not a surface or not a solid, it's something in between. Let's put it like that. And if you try with the Creo 9 or Creo 7 to measure the distance between the hybrid body and the real body or real kind of something else, you can't really make them act on the same measurement dialog. And now we can make them, coexist. So selection of those hybrid bodies are nowadays possible, and that of course makes it easier for you to validate the results. From the force perspective, for example, that greenish supporting structure for the chair is okay, but how about will fulfill some other requirements like safety distances to somewhere, or some other requirements that you might have. So it's now much easier to measure around with your CAD models to find out the situation. So that was my slide deck. Then let's see if we jump on the Creo Simulation Live thing in here for the contacts. So first of all, this is just an assembly with a few parts. So you have a few bars, you have one flat part, second flat part, and do something that might be bolts. So here's a one, and here's a corresponding nut, and same thing in here. And then when you go for live simulation, which is then launches the product called Simulation Live, you have basically options to run it as it was. So basically everything will be bonded, and I have that defined in here without contacts. So in here you have a load case where you support it with on the end, on the both ends, and then you on the other hand press it in the middle. So most likely this geometry will then be just a bend like a banana, and let's see what will happen. So if I just say, okay, please compute it for me, you will get early results already in here. I will just change the units for megapascal for the convenience, and you will find out that, okay, you have results which are roughly 30 megapascals. And then if you want to animate the deformations, you will see that, okay, deformations are there. But if you look at the stress results now, when everything is bonded, so it really means that everything is acting as a one single solid body. And you really don't see anything that, everything is basically merged together. So there's absolutely no sliding in this interface, for example. All the bolts don't really stretch because of the loading. So this is one way of getting some kind of an answer for it. But if you want to go a bit more detailed about what is really happening in here, then we have to start using contacts. And if I jump to second load case, I'm just getting the simulation off now, jumping to second load case in here. And in here, what we defined was the contacts. So in here, you have a bonded contacts, which simply means I bonded my bolts and nuts together so that they don't slide against each other. Then I have something called no separation, which means that we have a small sliding between this upper and lower bar piece of metal. And then on the other hand, between the the nut and the piece of sheet metal, same thing in here. And then on the top, between the bolt and the upper plate, you have the similar kind of no separation, but small sliding is allowed kind of a situation. And then we have some free, we don't really care kind of a thing. So, let's say no interaction between the bolt shaft and the hole. So they don't even know that they exist on the computational model. So there's a free, everything is free. You don't really see anything happening here. And same thing on the upper edge and upper in here. Now that is pretty much a contact definition. And you can recreate it here by starting contacts and just picking them one by one. And if you go this for the first time ever, it will basically bond everything together. And then you are capable of clicking that particular bonded one, edit that, make it a different one, if that is what you want to do. And now if we compute this thing, the result should be a bit different. And as you can now see, the stress distribution is quite different. Now this plate is also having a maximum stress on bottom and on top of the structure, and same thing in here. The previous stress concentration here is basically gone. And this is just now because of we have a bit different contact model in the system that allows the relative movement between the pieces, and thus making you able to find out that, okay, this is maybe a bit better description of how the system is behaving. But if you look at the bulk of the movement in here, well, we have pretty much a similar movement on the big picture, or let's say at the holistic model level. But movement itself hasn't really been changed, but how the pieces are interacting with each other has been really changed to this contact definition. Oops. Then there was this other model, Creo Simulate Compositing. And in here, I just modeled something, some kind of surfaces in the Creo Parametric, just to make sure that first of all, they are not any kind of cones or cylinders. The base shape is ellipse or something like that, and then you have surface rounds on it. So basically, these are double curved surfaces all around it. And if I take a quick peek of this composite tool, you will find that engineering composite, if you do have the license, you go and just say, okay, let's define some composite material. And how does it really go is that you have to have some composite materials in your models. And with the recent Creo installation, you do get some kind of a sample models for you. In here, I have a few kind of fun fabrics and one kind of foam material, which is in the model. After that, you define the layup surface, so basically a quilt where you start modeling. And then you define the basically global coordinate system where you define just the rotation or the orientation of laminates. So this is basically defining the zero direction, and then if you twist or rotate some of the fabrics, then it's defined basically based on that coordinate system. And you can of course have a multiple of them. So blue one with the blue star is just the active one. And then when you start defining your plies, you just say that, okay, this is my loop and this is my material. If you want to change the orientation, here you go. And then just go ply by ply higher and higher. And when you do make a laminate, and if I zoom this heavily, you will see that different colors now, first of all, represents the laminates on the model tree, but also you will see the thicknesses of this one. Since sometimes these things are something like a 0.2 millimeter thick, and they start then to be quite difficult to see. So we can also scale the thickness for the thickness direction so that you can really see. And it's also quite beneficial to see that, okay, what is my laminate look like? Did I remember all kind of fun, like this core material that I haven't put that into place. And at the end of it, when I'm kind of have, okay to my situation, I can also make my draping simulation to see that, hey, in here we have some risk of, wrinkling, and in here you definitely have to do something. And there's a kind of a preview of this fabric when it's unbent, how should it look like? But let's go this on the next webinar a bit more detailed about how this composite modeling is working. I was just willing to show you that, hey, this is containing all the plies, all the cores, whatever there might be that you need. Then when you jump from here to Creo Simulate, the PTC application, you can also put your forces and your constraints and your whatnot in here. Just thing that I learned by myself by making mistakes, of course, is that since this thing is defined so that you have your basic kind of quilt, which you use for making the layup, then you also have this kind of a boundary curve for that. And you actually use that very curve to define the boundary conditions. If you use kind of a, let's say, a modeling operation like a trim and cut away this kind of excess material in here, then and use the edge of this quilt, then the system is basically failing for you. So can't really get anywhere. But other than that, I just put some force on top of it, and then if you go for your results, there's definition of this one is there's nothing special in here that you have to do. Just use everything is default for me in this presentation. And I just want to see the results which are pre-computed. And if I look at for stresses, which in this case are, let's say, max principle in top of the layer of what first ply. And as you can see, you can get my ply by ply results. So these are just results of this, maximum principal stresses over the system on this first laminate. And if you just copy this thingy, let's say go for the second laminate layer, which has a bit different properties, you will now notice that, hey, stresses varies quite heavily based on the laminate and the fabric and its orientation. And yes, then there's an additional question about how do you then interrupt when it's breaking, but let's not go on that one. Second thing, since these are shell models, even though they are composites, the computational speeds are quite nice. In this case, where do we have it? Let's go here somewhere. I'm just trying to find out of my. We are talking about something like 7 seconds of total elapsed walk time on your wall. So in order to get kind of a ballpark feeling that if your laminate is sensible or not, this new extension of this Creo Simulate enables you that you can really take your laminate design very early in the design phase and just put it in the simulate, compute it, look at the results, and the results are dead fast for you. So basically jumping back and forth, think about, okay, is this enough of, let's say, laminates, enough core material for you so that you will kind of forget let's say the displacement, for example, within the specifications. It's quite fast to jump back and forth and quite efficient for you in that sense. But hey, this kind of closes down on my presentation. I think I have plenty of time for any questions. Should you have one? Do we have one? There's something on my chat, so. But that's not really a question.
Well, we have one question.
Yeah, Henrik is typing his here, so let's see what comes up.
Oh, but we have one before Henrik as well.
Okay, shoot.
So we have this one. Can you read HD F5 from composite design to ANSYS mechanical?
Yeah, very good question. So if you do a composite design and you can then push the whole definition, the geometry and the materials and the material orientation and layup sequence to this kind of specific transfer file, which then is readable to most composite calculation applications if you want to go really in-depth analysis for it. And ANSYS mechanical happens to be one of them. So yes, it's possible.
Great. And while Henrik is typing, why should people participate in the next webinar on Thursday as well?
Well, the next webinar on Thursday, we try to really go through what's new in Creo. Then for the modeling side of it, rather than the computational side of it, we will go through these composites a bit more in depth, but also all the good news about what's there for the basic modeling purposes, what's for them for mannequin, what's there for electrical designs, and all kind of news. So if you just want to keep yourself updated about where are we going, where are we heading, that would be the great presentation to go for.
Fantastic. And now Henrik has put in his question, and it is CPU multi-threading. Is it available in Creo 10 or is it planned?
Now I have to ask additional questions. What do you mean by that? So if you look at this one, for example, you can clearly see that if my wall time is on the clock on the wall is 7 seconds, but the CPU has been working on the 8 or 9 seconds, clearly we have to have a multiple CPUs working on it. But if you mean, so this is for simulation application. But if you mean the Creo Parametric basic application, well, I didn't dig out of any of that for this presentation, so don't know. I will answer that for the next one, if possible.
Great. So if we don't have any more questions, we see one here. We see Tobias is typing, so a little bit, we'll just wait a second here for him. We have one from Johan. Taking advantage of GPUs, is that something on the roadmap?
If you mean basically basic Creo taking advantage of GPUs beyond basic, so to basically use that for the computational power, no, I haven't heard anything of that yet. Yes. But again, I promise honestly to dig up that by Thursday as well. And basically making a slide for these questions. If you have any other questions like this, I made a slide for you guys, so we will get back for you.
Fantastic. And you can always reach out to you, Mikko, if there is any specific questions about this, and we can bring it up on the next webinar. But we now have one more question. Can ANSYS handle nonlinear with shell elements like plasticity?
That's a tricky one. So if you're meaning this Creo ANSYS simulation, haven't really tried that, but let's get back to this as well. Well, there's a non-linearity in there, there's a shell elements in there, but haven't really tried that one.
Mm-hmm. That is a
so
perfect
I'll
one.
get back also for you that one. These are great questions. They are detailed and
Yes, they're brilliant. So this is great. Now we have even more things to bring up on Thursday.
And there's one more coming from Johanna again. So let's see. Hopefully this goes something like let's answer it rather than let's postpone it. So nope. But hey, I'll get back to you on these questions, and since there's nobody's typing anymore, so no, he's typing.
Ooh, there are many cliffhangers here going on today. That's brilliant. Yeah, well, there is so many new features and functions in the Creo 10 that it's hard to be able to fit in everything in just 45 minutes. So let's see. Okay,
yep.
so large.
Yeah, I get back to that one as well. So I'm just, as you can maybe see, I'm sharing my screen, so I'm just about to create some kind of a geometry and try out and get back with you with the results. So okay, that is our approach on this one. So otherwise, you have to watch me failing miserably a few times, and that is not fun for anyone. So hopefully this is okay with you guys.
Absolutely, trial and error as well. But fantastic. Thank you for all of the questions. We will get back to some of them for the next presentation. And I hope to see all of you on the next one on Thursday, 9 a.m. Thank you, Mikko, for all of your efforts. So we'll see you guys on Thursday.
Thank you, everyone. Once more.
Thank you. Bye.